Hello, ladies and gentlemen. This video, we're going to take a look at some trig proofs today. So we're switching gears a little bit away from the whole idea of simplifying, so always making your expression simpler, instead to try to prove something else that's being requested, okay? This looks a little different than a geometry proof. Here are some general strategies that we're going to be talking about, like in general, how you do a proof in the algebraic sense is you're going to begin on one side of the equal sign. You're only allowed to change one sign of, or one side of the equal sign, okay? You can't change both. The proof ends with the expression on the other side. So we begin on one side and we work our way till it looks like the other side. We show the sequence of expressions, each one easily seen to be equivalent to its preceding expression. So that means we need to show each and every step. That's what constitutes a proof. So I need to show all my work. This is the annoying part, I know. Show all parts, all work along the way. This is the proof form, okay? You're not just saying, well, obviously it equals 1, duh. You have to show why it is, okay? And we aren't going to necessarily write all the words out that show that, but we are going to show the algebraic expressions to make that happen. One common hint is to begin with a more complicated expression and work your way to the less complicated one, because that's kind of the frame of mind we're in, right? We're always thinking about simplifying now. And if you get stuck or no other move suggests itself, meaning I'm like, I don't know what to do, you might convert the entire expression to one involving sines and cosines and see if that gets you someplace. Okay, remember we're still going to be combining fractions with common denominators. We're still going to use some factoring identities. Okay, so factoring can help if we need it, okay? And always be mindful of our target, what are working our way towards. And we can favor manipulations or things that we do along the process that bring us closer to our goal, okay? All of those strategies are going to become more clear as we work on some trig proofs here, all right? So here are some simple examples to put in our notes, and I'm going to, because there's a lot of examples here, I'm going to probably make a second video here with some tougher ones, but this is just our first go at proving, okay? So let's prove some identities. Notice that this one says we want to show that the sine of x minus the cosecant of x is equivalent or equals the negative cosine x cotangent x. We're not working it to be simplified. We want to take this side and work it to become that side. So I'm starting with this side over here because it's the more complicated one. It has a minus sign in there, okay? It has two terms rather than one term. And I'm going to start over here with doing what we know, replacing things that we know are equivalent. So the sine of x is just the sine of x, but from our previous work, we know that the cosecant is 1 over sine. So this is 1 over sine of x. Now my next move would be, well, let's make common denominators, right? We want to make sure we can subtract these two values. So my common denominator would have the sine of x on the bottom, which this fraction already has, so I'm going to leave it as a 1 over. And then this guy would become sine squared of x, okay, which is equivalent, now with the same common denominator. So now if I subtract across the top, I'd have sine squared x over sine x here, sine x squared x minus 1, make a single fraction. We know that this sine squared x and a 1, this relationship we've seen before, sine squared plus cosine squared equals positive 1. So if I change around that formula a little bit, that whole expression turns into the negative cosine squared over sine x. Now, please remember where we're trying to work ourselves to, right? This is where we want to consider our goal. Look up here. What do we have going on? We have a negative sign. Already have that. I need some cosines that are involved. Already have that. And I need to somehow get a cotangent out of this. Well, looking at my expression down here, what if I simplified or I changed my cosine squared into a negative cosine of x times another cosine of x, but this one's going to be over my sine x. Remember, when you multiply fractions, they just go straight across. That's what I'm saying here when I'm multiplying. This is still negative cosine squared, but now when I look at that value, I'm like, well, wait a minute. Cosine over sine is cotangent. So I have negative cosine x times cotangent of x. I have proven that the left side here is in fact equivalent to my goal up there, my right side. Okay, so you manipulate one side to try to get it to look like the other. In many cases, this is not the same thing as simplifying. We might have to, keep in mind our end goal, but we don't want to just go through simplifying the whole thing. Okay, let's look at number 2 here. What if we have 1 minus cosine being squared, and we have plus 2 cosines, and we want to turn it into or make sure that it's equivalent to sine squared x plus 2 cosine squared x? Well, I'm going to start on the more complicated side, ladies and gents. That'd be this side over here, right? There's a lot going on over there. We got a lot of terms. We got a bunch of squaring. So first thing I want to do is square this side. So 1 minus cosine x being squared is 1 minus cosine x times 1 minus cosine x. So if I multiply that out, I'd get 1 minus 2 cosine x's plus cosine squared x. That's what I get when I go, woo, woo, multiply this guy all out, right? Okay, then I'm just going to drop down the next part, plus 2 cosine x. Now I want to keep working this left side here. I'm just going to write completely underneath of it. I'm trying to prove that it equals this side over here, but I'm just going to work the left side. I can't work both sides. So now if I add these two things together, notice I have a negative 2 cosine x, and I have a positive 2 cosine x. Well, you guys, those would cancel each other out, right? So I have 1 plus cosine squared x so far. Now this is where it's weird. Like, well, where do I go from there? Remember, I'm not simplifying. I'm trying to get it to look like this. So my end goal needs to have some cosine squared x's in it, which I already have. But it also needs to have a sine squared x in there. Somehow I need to start bringing a sine squared in there. Well, 1 is equivalent to sine squared x plus cosine squared x, right? When I add those two together, I get 1. So that is an equivalent expression. 1 is the same thing as those two being added together. Well, now I'm going to drop down my other cosine squared x. And now if I add together what I have here, I have sine squared x plus 2 cosine squared x. Is that my goal? Is that what I was trying to get to? Yep, I got closer to my goal. This side does in fact equal the right side here. Whoops, my other right? Cosine squared x. They are equal to each other, and I proved it by working one side of that until it became equivalent to the other. Okay? Let's look at a third example. This guy is crazy fraction, pretty crazy fraction over here. Remember, one side kind of looks more complicated than the other, and that's this side right here. So I'm going to work my left side again. So 1 minus cosine squared x, I'm going to rewrite that as just being the sine squared x. It's equivalent. How did I know to do that? Because I'm trying to get some signs up on the top. That's my end goal. Check that out. I need signs on the top of the fraction. I'm going to need to start putting them in there then, okay? We also know from our properties that 1 minus cosecant squared x is the same thing as negative cotangent, my bad, squared x. Remember, if you rearrange that formula a little bit. So I'm working the left side and I've gotten to this point. Well, I already have some signs going on the top, but I feel like I need some more signs, right? Going up there, and I don't want a cotangent down here. I'd rather have some cosines. So I'm going to let the top of that fraction just sit there a little bit. But the bottom, we know about cotangent. Cotangent is cosine over sine, so this would be cosine squared x over sine squared x with a negative sign, right? Because it's a negative cotangent. Well, I'm dividing by a fraction, so I could multiply by the reciprocal. So I'm going to have my sine squared x times negative sine squared x over cosine squared x. Remember, I'm going to multiply by the reciprocal of that guy. So now if I multiply straight across, what do I have there? I have negative sine to the fourth, a sine squared times another sine squared, all over cosine squared x. There we go. My final answer, what I was trying to prove, I worked it to get to that place. It didn't necessarily look simpler, didn't get down to a cotangent or anything, but we did accomplish our end goal, was to make it look like the right side. Let's take a look at number 4. Which side looks a little bit more complicated? I feel like I'm going to go over here because this actually has two terms, so I feel like I might need to make some common denominators or something. I feel pretty good about that. I'm going to go over here. Yes, this side does look more complex, but I feel more comfortable working the left side on this one. It doesn't matter which side you choose. You could totally choose the other side if you wanted to and start working it till you get there, okay? But I'm going to choose this side. What about the cosine x plus a secant we could turn into 1 over cosine. And now see how I have a fraction? I'm going to make some common denominators here. All right, so I'm going to go cosine x on the bottom, cosine x on the bottom, 1 chilling up on top. This guy, when I put a cosine on the bottom, would become a cosine squared when I put another one up on the top. So if I add these two together, I have cosine squared x plus 1 all over cosine x. Now I need to somehow look at my end goal here, see if this is getting me any closer. Well, I do have a cosine x on the bottom, so that's good. But am I accomplishing my goal? Somehow I need to get this cosine to not be a cosine anymore. I want to turn them into some sine squareds, right? Somehow I want to do that. So let's think about what we could do in terms of cosine squared x. What could I replace that with that would bring in some sine squared? Well, the cosine squared x is the same thing as, oops, 1 minus the sine, oh, geez, my tablet's not writing very good here. 1 minus the sine squared x, and then I'm going to add a 1 to that. I'm just using the brackets to sort of emphasize what I plugged in, okay? Over cosine x. Now I'm going to rewrite that a little bit so you can see it. Combining my 1's together. 2 subtract sine squared x. 1 plus 1 makes 2. All over cosine x, which is my goal, so I did write a correct proof right here. Accomplished my goal. Okay, let's look at a fifth one. Boy, they just keep coming, don't they? Again, I feel like I'm going to work the left side here because I see something. 1 plus the tangent squared x is the same thing as a secant squared x. And that'd be nice if I was trying to simplify, but I'm trying to turn it into this business over here. So, noticing that I need some fraction going on, I'm going to turn this secant squared into a fraction. 1 over cosine squared x. And then I feel like I might want to bring in some sine squareds. Well, yeah, cosine squared x is the same thing as 1 take away sine squared x. Okay, so I'm basically undoing the simplifying there by saying I wanted it written like this. That was what I was trying to prove. But cosine squared x is the same thing as 1 take away sine squared x. And that was what I was trying to prove. So, yay, I accomplished my goal. All right, should we do one more? Oh, yeah, we got time. Here's number 6. Sine squared x times cosecant squared x all over cosecant squared minus cotangent squared. And I want it to make 1. So I want to break this stuff apart here or try to work this side to make it all work out to prove that it's 1. So on the top of the fraction, I'm probably going to start there. Sine squared x. Cosecant squared is 1 over sine squared x. So I have a sine squared up and a sine squared down up on the top of this fraction, so they would cancel. All I'd have is a 1 over cosecant squared x minus cotangent squared x. Well, what am I going to do with that? What's that? Well, cosecant squared is the same thing as cotangent squared plus 1. Now I'm going to take away that cotangent squared according to the rest of the denominator there. So I end up with 1 over 1 is my answer, which equals 1, what I was trying to prove. Okay? So that's sort of how a trig proof works. You want to work one side to try to accomplish your goal on the other side. We sort of have to fight the urge to always simplify. We always want to look at our goal and go, am I getting closer to that? What do I need yet? I need more sines on the top, or I need more cosines on the top in order to accomplish that mission of proving what we're trying to prove, okay? So I want to thank you for taking good notes. Kincaid out.